Okay, let's do some practice. We've encountered several rules so far, and it's time we try some challenging problems and see if we really understand what we've learned. Why don't we quickly just write down the rules that we've learned so far? We've learned that the derivative of a constant is zero. That's called the constant rule. We've learned that the derivative of a power is n times x to the n minus 1. And there's two special cases of this rule that's worth memorizing and they're by themselves. And that's the derivative of x is 1. And the derivative of root x is 1 over 2 root x. Okay. And then we had the little rule that if you have some number in front of some function f of x and you want to do that derivative, all you do is you bring the number to the front and then you multiply by the derivative of the function, okay? And then finally we learned the rule for the sum of two or more functions. If you want to do the derivative of a sum, you just do each derivative individually. And same with the difference. I'm only writing down the formula for two functions, but even if there's many functions in here and you have plus and minus signs all mixed together, you just do the derivative term by term, okay? Okay, good. And, this is the same thing as c times f prime of x, okay? Whichever one you prefer. It's the same thing. So this is our toolkit. I want to do 10 problems right now. The first problem is f of x equals 3 to the power of 21. What is the derivative of that? Okay, now you have to be a little careful. Maybe some students might be tempted to do something like, well, you bring the 21 to the front, and then you do 3 to the power of 21 minus 1, which is 20. And that would not be good because you're using if you do this, that means you're using the power rule. But the power rule needs an x in there, right? This doesn't have any x in it. This is just some number, isn't it? So instead of the power rule, we should actually just use the constant rule. And even if your constant is written in a weird way, like 3 to the power of 21, the derivative is still 0. That's all there is to it. Let's try this one. Let's say f of x is pi to the power of 3 over 4. Again, this is easy because even though, this is just a number, right? It's kind of a complicated number, but it's still just a number. And so that means the derivative of that is going to be 0. Again, the constant rule. Now, we have to get used to using all the time I've been using little f and x, okay? But you really have to get used to using any letters, okay? How about we write capital F of x instead of little f and try a question like that? Let's say we do something like this. How do we find the derivative of this? Well, I'm going to use this rule here, constant times a function, in conjunction with the power rule. Okay? So to do this derivative, what I'm going to do is first just pull out the constant out front and then multiply afterwards by the derivative of x to the 10. And to do the derivative of x to the 10, let's use the power rule. 10 x to the 9. And then simplify a little bit. 5 goes into 5 once. 5 goes into 10 twice. 2 times 2 is 4. So it's 4 times x to the 9. And by the way, it's good if you would pause the video and try these yourself before I write down the solutions. And that way you will get more benefit out of it. Especially if you get stuck on a problem, then you can, see how I do it, and then you'll learn from that. How about we try this one? F of x equals polynomial, let's say 2x to the 4 minus 3x squared plus 2x plus 7. So pause the video and try that. To do this derivative, we're going to use the sum and difference rules to allow us to do the derivative term by term, okay? And we're going to use the constant rule to bring these numbers out front, and we're going to use the power rule. Now, how about I just go, let's kind of go fast on this one. To do this derivative, like I said, we're going to do the derivative term by term. What's the derivative of this first term? Well, it's 2. I'll bring that out front, and then multiply by the derivative of x to the 4, which is 4x cubed. And then this minus 3 is brought out front, times the derivative of x squared, which is 2x. Bring the 2 out front and multiply by the derivative of x, which is 1. We memorize that. And the derivative of 7 is 0 by the constant rule. And we get 8x cubed minus 6x plus 2. We don't have to write that 0. And you know what? You can just, if you wanted to, you could go directly from this step to this step in one shot. You don't have to bother with this. Kind of think of it as 2 times 4 is 8, right? And then bring the exponent down by 1 to make it into a 3. And then 2 times negative 3 is negative 6. Subtract 1 from the exponent, you get 1 here. You don't have to write the 1 there. It's best if you don't. There's no need for it. Here we have the derivative of this is 2 times 1, which is 2, and the derivative of this is 0. So that's not too hard. How about we try one where we have a different letter? Okay, let's say something like, let's use, instead of x, why don't we use t? F of t equals 1/3 t to the power of 5 minus 8 t squared all over 5. And then plus t. Now, there's a little issue here. This left term and this rightmost term are ready to go. But this one doesn't quite look right because it's a fraction, and we haven't really talked about how to do the derivative of that. But let's prepare this function. Before we do the derivative, let's just prepare it a little bit. We'll keep this the same. But instead of having it like this, let's make this out front. Okay, let's write this as minus 8 over 5, and then center the t squared beside it. Okay, that's certainly a real basic rule of algebra. It's actually a very useful rule to remember that kind of trick. Okay, it's sometimes if you have something like x over 5, for example, we can write that as 1 over 5 times x, right? And sometimes that's nice because it kind of separates the expression into a number out front and then the letter, the variable. Whereas here we have the variable over the number. And sometimes it's nice to work like this. Sometimes it's nice to work with this one. You have to realize that they're the same thing and choose the one that's best for you in any particular problem. Here we want to do that because when it's like this now, then I'm all set up to use this rule here, constant times a function, right? My constant is negative 8 over 5, and my function is t squared. All right, so let's do the derivative. The power rule, I said for x, right? I said the derivative of x to the n is n, x to the n minus 1. But whether the variable is x or t, it doesn't really matter. You can use the same principle. The derivative of t to the 5 is going to be 5 t to the 4, right? So the 1/3 comes out front using the rule right here. And then we multiply that by 5t to the 4. And then subtract 8 over 5. And then the derivative of t squared is 2t to the 1. But I won't bother writing the 1 since it's unnecessary. And just like the derivative of x is 1, the derivative of t is 1. So there we go. That needs to be simplified. I don't really have room. Maybe I'll just try to squeeze that in here, okay? So just grab a little bit of space here. So the final simplified version of that would look something like this. This can be, this 5 is 5 over 1. 1 times 5 is 5. 3 times 1 is 3. So this is 5/3 t to the 4. And here we have 2 over 1, 16 over 5 t. And the plus 1 is just recopied. Okay. So that would be the final answer for number 5 here, okay? Why don't we go to a new page? Let's do number 6. Number 6 is going to be, let's see here. How about we try f of t equal to 5 minus t over 4. Pretty simple. Again, I think I want to prepare this a little bit. It's not quite ready to have the derivative of it. Because t over 4, it's kind of problematic. We want to get the number in front of t. We don't want to have t over a number. We want to have a number in front of t. So let's just use that little trick or that little algebra idea there, that we just bring the 1 over 4 out front like that, right? Notice I have not done the derivative yet. This is just preparing the function to be in a nice form in order to do the derivative. But now I'm ready. So let's do the derivative, okay? Well, this is a difference, so we're going to do the derivative term by term. The derivative of 5 is, 5 is a constant, so the derivative of 5 is 0. Minus 1 over 4. I bring that out front, and then I multiply by the derivative of t, which is 1. And that simplifies to simply just negative 1 over 4, right? So there's the derivative there. For number 7, why don't we write it as g of t? Got to get used to these different letters of these function names. How about 4t to the negative 7 over 2? Okay, well, the derivative of that is going to be, let's first pull the 4 out front, and then inside these brackets here, we're going to multiply by the derivative of t to the negative 7 halves. And that's just power rule, right? N is negative 7 over 2. We bring the n to the front, and then our variable t, and then negative 7 over 2 minus 1. What is that? Well, we can write 1 as 2 over 2. And so this is negative 9 over 2. Sorry, it's a little bit messy. Negative 9 over 2. That's what we should put right here on the exponent. Remember, this exponent is n minus 1, right? We need to clean this up a little bit. The derivative is done, though, right? There's no more prime signs, so we just got to use some algebra here and clean this up. 4 divided by 2 is 2. 2 times negative 7 is negative 14. And let's get rid of this negative exponent by bringing it to the denominator. So negative 14 over t to the 9 halves. There's our answer there. How about we look at this one now? Let's start getting weird with our letters. Let's say a of s. Just like f of x, just different letters. S is your independent variable. A is your dependent variable. Just like x is your independent variable and y is your dependent variable. So let's say this negative 4 over s to the minus 2. Definitely looking a little bit weird there. We definitely need to prepare this function. It's not ready to go right now. What I would do is first rewrite it. Let's bring, this, when you have a negative in front of a fraction, you can do this, right? Like when you have a fraction We talked about this in the review, that if you have negative in front of a fraction, like centered out front, that's the same thing as putting the negative on the top or putting the negative on the bottom. All three of these are the same thing. And we don't like having the negative on the bottom. Putting the negative in front or on top, both of those are preferable. But for this one, I kind of want to put it up top, just to join the negative with the 4 there. It's going to make it nicer. And also, this s to the minus 2, let's bring that up to make it s to the positive 2 up there. So it's negative 4s squared. Now it's not looking too bad. But I hope you realize we haven't done the derivative yet. We've just prepared it into the function into a nice form in order to use our rules. So here we go. The derivative of a of s is going to be what? Well, let's pull out this constant out front. And then afterwards, we're going to multiply by the derivative of s squared. Well, the derivative of x squared is 2x to the 1. So the derivative of s squared is 2s to the 1. And I'm not going to bother writing that 1 because it's unnecessary. You could. It just kind of looks silly because you don't need it there. And then just simplify it, so negative 8s. That's our final answer there. All right, number 9. Let's do this one. Y equals x to the 3/5 minus x to the 5/3. How do we do this derivative? Well, this is the first one where I used y. All the time here I had like a function f of t, g of t, a of s, f of x, blah, blah, blah. Here I'm just using y, and that's fine. Y is the same as y of x, okay? Y is really a function of x. We just don't write it, okay? So instead, just like we write y prime, we write y prime of x. Those are all the same. Got to get used to these different notations for derivatives. Okay, this is an easy question here. We got a difference of two functions, so we're going to use the difference rule, which just means we're going to do the derivative of this minus the derivative of this. And how do we do each of these derivatives? Well, power rule. So in this first one, n is 3/5, so bring that to the front. And then we do 3/5 minus 1. I hope you understand that that's minus 2/5. Minus, here we're going to bring 5/3 to the front. X to the 5/3 minus 1. That's the same as 5/3 minus 3/3, which is 2/3. And this negative exponent kind of stands out. Why don't we rewrite it without that? And we get 5x to the positive 2/5 minus, and this one we can keep the same. And there's our answer there, okay? Let's do one more. Let's say, question 10 here. Let's get even weirder with our letters. S of p equals root p minus cube root p. All right, so we've memorized the derivative of root p, haven't we? It's 1 over 2 root p. How about we not even use that? Let's just do this from scratch. Root p is p to the half, right? And cube root p is p to the 1/3. So now we've prepared our function, and now let's start on the derivative. It's 1/2 p to the power of 1/2 minus 1, which is negative 1/2. We're using power rule here, right? And we're going to use power rule again here. This is 1/3 p to the 1/3 minus 1, which is negative 2/3. And we've done the derivative. Maybe we should just clean it up a little bit, though. So this is 1 over 2 p to the half minus 1 over 3 p to the 2/3. And we could leave it like that. Or we could change it to root signs. Really, it doesn't matter. Just for practice, why don't we do that? And no surprise there, right? The derivative of root p is 1 over 2 root p. We knew that. We've memorized that. Here, this is, remember the bottom number, the denominator is the index of the root. That's the number that goes inside this little root space here. I didn't bother writing it there because if there's nothing there, we know there's a 2 there. But in this case, we actually do have to write it. So let's write a little 3 here. It's inside the root index. And under it, we have p to the power of 2. So both of these are acceptable answers. It really depends on your teacher which one they prefer. But to mark one of these wrong is kind of silly because they're both just fine. Whereas this one here, it does have negative exponents, and so that you might lose a mark or a half point or something if you don't convert that over to positive exponents. But in terms of these two, both of them are just fine. Okay, so we've practiced some questions now. You see that they can get a little bit harder. On the next video, we're going to do some more practice, and we're going to boost up the difficulty a little bit more.